Hey guys, so there are a lot of advancements that keep happening in the RAG ecosystem, and one such thing that is getting more attention these days is knowledge graphs, enhancing RAG applications using knowledge graphs. So today's video is all about understanding knowledge graphs and how they basically enhance the RAG applications. So let's get started. So let's understand what are knowledge graphs first, right? So knowledge graphs are structured ways to organize information showing how different data points are connected, right? So they are basically used to understand the relationship and context among different data points effectively. So now think building such knowledge graphs and feeding it to our RAG applications, right? That will be really amazing. As you can see in the image, it's just a simple example of a knowledge graph, right? Where you can see dog is an animal and cow it eats herbs and herbs it is a plant and her plants is animal thing living things. So it's all connected, right? So all these data points have some context and they are all connected somehow to each other. So these knowledge graphs significantly augment RAG systems by providing structured and semantic context, right? So that improves data retrieval accuracy and efficiency. So that's how useful the knowledge graphs are. So in the next part of this video, let's understand in depth about knowledge graphs. If you are new to RAG, retrieval augmented generation, and want to understand what it is and why it is required, let's understand, right? So we need to understand one thing that these large language models basically sometimes hallucinate. They provide answers or responses that are inaccurate, sometimes biased, and sometimes made up answers, which we don't want in our AI applications, right? We don't want such LLMs, and we want to mitigate this behavior of large language models. So there are basically three strategies or approaches we can say. One is fine tuning, second one is prompt engineering, and the third one is RAG, retrieval augmented generation. Fine tuning is where you basically take a pre-trained model and you train that model with your custom data, right? And that's how the model will understand the new vocabulary and how to respond back to the user. And you can use that LLM in your AI application. And the prompt engineering is basically the art and science of playing with your prompts, using different prompts and seeing the answers, and basically it's all about the prompts. And RAG is where you augment the knowledge base using a vector database, where all your information what you want is all stored in a vector database, and whenever a user query comes in through vector search, the similar chunk is retrieved back, and it is given back to the user as a response or answer. So in all these three strategies, there is no chance of hallucinating, right? We are basically mitigating the LLM hallucination, LLM hallucinating behavior with these approaches. So that is where and in these three approaches, RAG is considered one of the sophisticated approaches. So here is a simple RAG workflow if you want to understand more about retrieval augmented generation. It's basically an approach that leverages external data source stored in a vector database, right? Specialized database, what we call vector database. So yeah, if you can see in the left-hand side, the documents, they get split, basically the chunks are created from the whole document, and it goes through an embedding model. There are different embedding models from different platforms like OpenAI, Hugging Face, Cohere. All these platforms provide you with different embedding models. So these chunks go through the embedding model, and that's how vector embeddings are created. And these vector embeddings are stored in a vector database. As you can see, there's SingleStore, Chroma, Lance, and Waviate, Pinecone. There are many others. So this is about the storage of vector embeddings, right? And what happens when a user query comes in? As you can see here, when a user query comes in, even the user query gets converted into a vector embedding using vector embedding model, embedding model. and then it goes through the vector database to retrieve the similar chunks using vector search and semantic search. And now that you have the prompt, you have the query and the context and the retrieved chunk, it again goes through the LLM large language model to answer back to the user, right? So this is a simple RAG workflow, and yeah, so in the next part of this video, let's see more about how we can use right knowledge graphs in our RAG application. As you can see, here is a knowledge graph RAG workflow where the user query gets converted into a vector embedding and is stored in a database. You can call it a vector database or graph database, right? You just need a database here which can handle that type of data. And now that we also have our knowledge graph constructed, right, with all the entities and the relationship defined, and uh, and then that goes through the LLM to respond back to the user. So now we have more context, and the answer that the user gets is also more accurate and it is more enhanced. So that's how we can feed knowledge graph in our RAG application and basically enhance our RAG application. Hey guys, so let's create a simple RAG application using knowledge graph. Okay. Here we will be using SingleStore database as our knowledge graph database. Yes, you can use SingleStore as a vector database and also as a knowledge graph database. So it can handle multiple type of data and it started supporting vector storage long back in 2017 itself, and that's why SingleStore is considered one of the robust and all-in-one data platform. So first things first, go to singlestore.com, sign up, it's free, and create a database. Once you create a database, try to create tables. So we will basically create a database and we will create two tables, namely entity and relationship. We will insert various entities into the entity table, and each entity has an ID, a name, and a type, and we insert various relationship between these entities into relationship table. So now that we have built knowledge graph, the next is query the knowledge graph using different words. So we will use different words like Mario and Nintendo. So basically, we are using dummy data of Super Mario game, and we are basically loading it to our database, that is single store database, and um, we are basically querying it and seeing the relationship and even the score for that relationship. Okay, so let's do that. Hey guys, so sign up to singlestore.com, use the free share tier, it's free forever. And once you sign in, you will land here basically, and you will have your workspace ready by default. And if you don't have one, you can create from here, create workspace. And under your workspace, you have the ability to create a database. So you can create a database just by clicking create database. So I already have my database ready, that's graph database. GraphDB is the name, and you can create yours from here. And then once your workspace is ready and the database you created, go to Data Studio and open the SQL editor, because that's where we're gonna work, right? So once you open your SQL editor, this is where you land. And basically, for the first things to select your workspace and select your database from here from the drop down. And like I said, we're gonna create two tables under our database. That is, one is entity, the table name, and the second one is relationship. And then we're gonna feed some data to our entity and the relationship table, and then we're gonna query the first query is Mario, that is the word we're gonna use, and the second query that we're gonna use is Nintendo, right? So when you use the first query Mario, And once you run it using the run command, run button here, you can see wherever there is Mario, it is retrieving back with the entity name and the relationship, the type, ID, and also the score that particular text is matching with. And once you run for the word query for the word Nintendo, here you can see the relationship for that, right? Nintendo, right? And also the score. So this is how you can build, construct a knowledge graph, insert it into your database, and then retrieve back the results for the query, right? So yeah, I mean, you can let me know if you have any questions. I'm happy to answer, but this is the way to do. And I'm also gonna write complete article on this so that you can go through and try to uh, do this tutorial and understand how knowledge graphs are useful in our applications, right? Hey guys, so I just wanted to confirm one thing, that this is not a full-fledged RAG application, what we saw today in this video, but hope you get an idea. This is what we saw today was just an example of how you can construct a knowledge graph and use a database like SingleStore to store your knowledge graph, so that when you feed it to your LLM in the RAG application, you get contextually relevant and more accurate results. So the purpose of this video was more on constructing a knowledge graph and how you can retrieve right the results, the proper results, highly accurate results, if I can say. That's it about, because in the beginning and in between, I saw myself saying it's a RAG application, but it is not exactly. Um, it is a simple, it's a simple, tutorial on how to construct a simple knowledge graph and store it in your database, and retrieving whenever a user query comes in, right? Retrieving the proper results. So yeah, go ahead, try this, and let me know. Thanks.